Hello everyone. In this video I'm going to explain the Lensmaker's formula. 1 by f equals to mu minus 1 by r1 minus 1 by r2 here. F is the focal length of the lens, the required focal length, and mu is the refractive index of the material with respect to air, absolute refractive index. And r1 and r2 are the radii of curvature of the two surfaces. The lens must be thin, but I have to draw it a bit thick. It is considered as a thin lens. Let mu1 be the refractive index of the rare medium. This is the denser medium. It has mu2, and this side again mu1. Let this be xy, the lens is xy. The pole on this side, let it be p1, this side p2, and this is the center of optical center of the lens, C, optical center. Here we consider a point object lying at the principal axis. This is the point object. From the point object, let me draw the incident ray. This is the incident ray. It suffers refraction at this surface xp1y. Then there will be a normal at this point. Let it be the normal. This is the center of curvature for P1, so it will be C1. This is P2. This is C1, and if we consider at the interface, this is then a rarer medium and this is the denser medium. It bends towards the normal. It bends towards the normal. Okay. Here it suffers again another refraction because of this curved surface xp2y, and the center of curvature will be on the left side. Here I am going to draw the center of curvature on the left side, and this is the normal. Here the ray travels from denser medium to rarer medium, so it bends away from the normal. So it bends along this, in this direction. This is the position of the final image. If the lens, the material of the lens fills all the space of the right side, if the lens material is extended on the right side, the image will be formed at this point, so it is I1. Okay. We are going to apply this formula, mu1 by u minus mu1 by u plus mu2 by v equals to mu2 minus mu1 by r for both the refraction. First, I'm going to consider xp1y, refraction through xp1y. The diagram will be like this. Ray travels from O. Here is the center of curvature C1. This is P1. And this is the normal, and This is I1. Okay. Here we consider the material of the lens is extended on the right side. This is the material of the lens. All this is filled with the material of the lens. This is mu1 and this is mu2. So let us apply this formula. Mu1 minus mu1, it travels from mu1 to mu2. So minus mu1 by u is P1O. It is negative. P1O minus P1O. It is taken negative since it is against the incident ray. P1O is from right to left. Plus mu2 by V is P1I1. P1I1. And mu2 minus mu1 divided by the radius of curvature is positive P1 C1. P1 C1. Negative and negative cancels. If we consider the lens is thin, the distance between P1 and C will be very small and it is negligible. So we can replace P1O with CO, P1I with CI, P1C with CC1, P1C1 with CC1. That means all these P1 are replaced with C. It becomes mu1 by CO plus mu2 by CI1 equals to mu2 minus mu1 by CC1. Let it be equation 1. Again, let us consider another refraction. Refraction at x, p2, y. X, p2, y. And the lens and the material of the lens extends on the left side. This is the principal axis. Here light travels from this, okay, and I1 is acting as the virtual object for this refraction, mu2 to mu1. Here, ray travels from mu2 to mu1 and C2. This is C2. So this is C2. This is the normal. It bends away from the normal since it is from denser to rarer medium. This is the final image, I. Here, ray travels from mu2 to mu1 because mu1 here mu1 will be mu2 and mu2 will be mu1. They will interchange their place. Let me apply this formula again. This is the virtual object. I1 is the virtual object. So what do we have? Mu1 is mu2. In case of U, P, and this is the object, so it will be U will be P2 I1. P2 I1 plus mu2 will be mu1. Mu1 by V is, this is the final image, P2 I. It is positive. P2 I equals to, oh, this will be negative. I forgot, this is negative. Mu2 minus mu1, so it will be mu1 minus mu2. mu1 minus mu2 by r, the radius is p2c, it is negative, minus p2c2. Then we have minus mu2 by, again, p and c, the distance between p2 and c is very small. We neglect this small distance and we replace p2 with c again. ci1 plus mu1 by ci equals to mu1 minus mu2. Applying this negative, multiplying with this negative sign, they will interchange their place. Minus mu2 minus mu1 divided by c2. P is replaced with c. This is equation 2. Now let us add the two equations, equation 1 and 2. Adding the two equations, this and this are same, mu2 c1, mu2 by ci1, mu2 by ci1. They are equal and opposite, so they cancel each other. Mu1, then we get, I think this 2, mu1 by co plus mu1 by ci equals to mu2 minus mu1 by cc1 plus mu2 minus mu1 by cc2. Here we can see that mu1 minus mu2 is common. Let us take the common, mu1 minus mu2. So we get 1 by cc1 plus 1 by cc2. Do not forget to write this bracket. Without this bracket, this quantity will be multiplied only with mu1. Now, dividing both sides with mu1. Dividing all the terms with mu1. Dividing both sides with mu1. Like mu1, mu1, mu1. Then we get mu1 by mu1 is 1. So we get 1 by co plus 1 by ci equals to mu2 by mu1 is mu. Mu2 by mu1 is mu. That is mu2 1. Actually it is mu2 1, but we write mu here. Mu2 by mu1 is mu. Mu1 by mu1 is 1. 1 by cc1 plus 1 by cc2. Okay. Now let us apply the sign conventions. One CO is the position of the object, but it will be taken as negative. And CI, that is the position of the final image, it is V, it will be taken positive. CC1 is positive, it is R1, the radius of curvature, and CC2 is R2. CO is minus U, so we can write 1 by minus 1 by U plus 1 by V, CI is V, equals to mu minus 1 by CC1 is positive R1, 1 by R1 plus 1 by CC true. CC true is negative, so it will be negative 1 by R true. Here we get this formula. But this is not the final equation. Now let us define the principal focus. First principal focus. Let this be the lens. The first principal focus f1. If we put the point object at f1, the image will be formed at infinity. Object placed at f, image at infinity. Then, on putting this value, then it will be f. Or let it be f1. Here, putting the value u is this definition of first principal focus. First principal focus. U is minus f1. Then v is infinity plus infinity. Then putting the value in this equation, we get 1 by minus f1 plus 1 by infinity equals to mu minus 1 by r1 minus 1 by r2. Okay, then we have 1 by f1 equals to, this is 0, 1 by f1 plus 0 is 1 by f1, mu minus 1 by r1 minus 1 by r2. Here, the first principal focus is the position of the object which produces image at infinity. Okay, this is for the first principal focus. Then this is the focal length, the first principal focal length. Again, let me define the second principal focus. Focus on the right side. The second principal focus. Suppose this is the second principal focus. It can be defined as the point at which all the refracted ray converges to after refraction, when parallel ray comes from infinity. Okay. Here we can say that the object is placed at infinity and the image is formed at f2. And this is the focal length f2. Here u is minus infinity and v is f2. U is infinity, v is f2. Then putting the value in this equation, it implies 1 by minus infinity plus 1 by f2 equals to mu minus 1 by r1 plus 1 by r2. Then this is 0. We have 1 by f2 equals to mu, the same result. We get the same result. That means f1 and f2 are equal. We can write f as the equality. So, replacing f1 and f2 with f, we can write 1 by f equals to mu minus 1 by r1 minus 1 by r2. This equation is called the Lensmaker's equation, Lensmaker's formula. Thank you.